Okay, today it's officially called sum and difference and double angle identities. At this point, if you haven't already, get out your white sheet that has got the identities on it, and I want to talk about the odd-even identities briefly. The first one says sine of negative x is equal to negative sine of x. All right. I've already... Okay, back with you. Sorry, we had a little announcement there. So this identity is saying if I want to find the sine of negative 30 degrees, I could just find the sine of 30 degrees and then do what? Make it negative, the opposite of it. So, similarly, what if I want to find the cosine of negative 60 degrees? Well, look at that identity. So here's what I would do if I was, faced with that question. Okay, they might say, find the cosine of negative 60. Instead of actually drawing the circle, if they say use the odd-even identity, I would write down the odd-even identity that goes with it. So everybody write that one down, and then underneath it, we're going to write down the odd-even identity that goes with cosine. It says cosine of negative x would be equal to cosine of x. I showed you yesterday why this was true. I'm just going to briefly remind you. If this is cosine of some angle, let's say 30 degrees, whatever it is, some positive angle, if I go down here and do negative 30 degrees, it's going to be the same. Because, students take calc, cosine's positive here and here. So whatever it was in this quadrant, cosine is, let's see, it's 1, 2, root 3. Cosine would be adjacent over hypotenuse, would be root 3 over 2. It's still going to be root 3 over 2 because with cosine, we never use this side right here because cosine uses adjacent and hypotenuse. All right, so long story short, we can trust that cosine of negative x is equal to cosine of x. All right, so now, how am I supposed to figure out cosine of negative 60? By finding cosine of regular 60. Do you see how this guides me to say that will equal cosine of 60? All right, so let's take a homework problem that is like this now. So everybody go down to day 1, and we'll do number 1. Ready? It says, use the odd-even identities. That's the ones we just talked about. It's in the little section on our trig sheet there. To verify the identity, assume all quantities are defined, as in, we're not going to give you any that are undefined, because if it's undefined, then the identities don't work anymore. Okay, so back to which even or odd identity works in this one? And I'd like you to write it right underneath the problem. Well, this obviously has to do with sine. So, IA, would you read me the one that has sine in it off the sheet? Sine of negative x, same as negative sine of x. Okay, cool. Now, look at what we have and look at what we know to be true. Do you see how the signers, these are matching up perfectly? And this is all matching up perfectly? So what do we really need to prove? That this and this are the same? Does the thing we know to be true say that that and that are the same? Is that what it says? No. It says one's negative and one's positive. What's that? What's the word for that? They're opposites. So do you get we need to prove that this and this, or verify, I guess you'd say, verify that those are really opposites? Now, from what I showed you yesterday about opposites, or in the video right before this, you remember if I had 5 minus 6, that would be the opposite of 6 minus 5? And how do you really get something to reverse like that? You multiply it by -1. Okay, so now, is this right here really the opposite of that? So you would write 3 pi minus 2 theta and 2 theta minus 3 pi, sorry. You could probably, if you weren't having to do this in a math class, just look at them and say, oh yeah, they're reversed, they're opposites, so I'm good. Okay, but we're not going to let you just do that. How would I set it up so that they're actually equal to each other? They aren't equal. What would I need to do? You need parentheses around them, and then they're still not equal. How could I make them be equal? Multiple one. Which side do you think I should pick, judging by looking at my identity? The left side has a negative in there, so let's put -1 right there. Now, shouldn't that be true? All right. So then, multiply that out and see if it actually is true. Is it true? When you multiply by -1, doesn't that switch these guys around? And then isn't this side truly equal to that side? And then do you get, I just verified that this will be true for this situation. All right, the one you're going to have to do for homework. That was your homework. I was just helping you with number 1, so it's not a waste of your time to write it down. But number 2. Number 2, what's the pertinent cosine odd-even identity? Mr. Z, would you read me the one that says cosine under the odd-even category?
Cosine of negative x equals.
All right. Now, does it look to you like what I'm trying to prove is once again that that and that are opposites of each other? All right. So your job then is to not really prove, because it says verify, but verify that that and that are opposites of each other. I'm not saying if they are or not. You should be able to know from what I just told you, but how you would tell. I'm going to pause for a second. All right, so let's look at number 22. This involves the cosine of alpha plus beta. See right here? For you to be able to do that kind of problem, I'm going to show you something about these identities that's on your sheet. Everybody look to the lower left-hand corner of your sheet. Do you see where it says sum/difference identities? All right, so look at part A here where it says cosine of alpha plus beta. Do you see that in your list somewhere, except it doesn't use alphas and betas, it just happens to use x's and y's, right? Which one of those lines would pertain? Do you see it? You see it? It's the one where it's cosine and it's adding. You see one where it's cosine with adding. Which one is it? The first, second, third, fourth, fifth, sixth, seventh? Which one? Third one. Okay, good. Would you please read me that one? Cosine. All right. Now, it wants me to do that same exact thing except with alphas and betas. So I want you to write down on your sheet, except every place where there's an X, you use alpha, and every place where there'd be a Y, you use beta. So this will be alpha plus beta. X is alpha. Y is beta. X is alpha. Y is beta. Now, I will prove this to you tomorrow, but judging by how little time we have, I need to just kind of plow forward here, not try to prove that this is true. For right now, just we'll accept that these are true identities. Okay, so now, if I want to get cosine of alpha plus beta, I got to do all this. This is how we tie it into last year. Last unit. On last unit, we were drawing triangles in certain spots and labeling their sides and trying not to forget about negatives? All right. That's the last unit. This unit, we mesh the two together. Right here, they're saying how alpha, or stuff about alpha, right there. We're going to draw a picture of that. Over here, they're saying stuff about beta. And that's a clue. Instead of saying it's in quadrant 3, they'll say pi over 2 is less than beta, which is less than pi. That's saying it's between pi and pi over 2. Do you know where that is? I hope you haven't forgotten. Here's where pi over 2 is. Where's pi? Way over there. And if you needed it, 3 pi over 2 would be down here. Remember that? Okay, so when they say it's between pi over 2 and pi, do you get they were kind of just saying it's in here? All right. So, everybody, start. We'll do this red one first. And honestly, I would like you to pick a red pen to keep these two separate. Since you have that option on your iPad, let's do red pen. And we're going to draw the triangle for that alpha angle. And over here, we're going to draw the triangle for the beta angle. And once we're done, we're going to use this boss identity and plug in cosine of alpha and cosine of beta and sine of alpha and sine of beta. All right, so one little step at a time. Where is quadrant 4? Point. Yep, it's in this spot right down here. So I'm going to cross off all of these. Would you agree I have left it with only quadrant 4? Okay, so everybody do that and draw yourself the classic triangle. We don't know how long the sides are, but put theta. Oh, wait, it's not theta. What is it? Alpha. Put alpha right there. And now it says cosine of that is root 5 over 5. Do you know cosine is adjacent over hypotenuse? So they're saying the adjacent side is root 5. The hypotenuse side is 5. And then, I don't know the last side. My technique was square root of, and then you figure out the other two things squared. And then in this case, do we add them or subtract them? Subtract, good. So 25 for this one, right? Minus, remember how to do that? Squaring something that's a square root. Root 5 makes 5. Good. So it's the square root of 25 minus 5, which is square root of 20. All right, and then most common mistake in circle trig, just to forget that that's negative root 20. Makes a big difference because then you'll have negatives in your answer. Okay, so now, do you get we have done alpha and we can now do cosine of alpha and sine of alpha? You get what I'm saying? That's what we need for that big awesome formula is cosine of alpha and sine of alpha. Later, from the green triangle, we'll get cosine of beta and sine of beta. See where I'm going with this? All right, so let's do cosine of alpha right here. That part. What is cosine of alpha? Well, here's alpha. Cosine's easy. It's adjacent over hypotenuse. Which is what? Root 5 over 5. And it says it right here. Cosine of alpha is root 5 over 5. So I can put that in. Root 5 over 5. Cool. Done. Now I got to get cosine of beta. Oh, wait, I don't have betas done yet. That's the green triangle I haven't made yet. Then it's going to ask me to do minus sine of alpha. I could do that. That's something new we didn't have before. Sine of this angle, alpha, is opposite over hypotenuse, negative root 20 over 5. Minus negative root 20, notice it's a minus a negative, over 5. It's actually all in parentheses. This minus is built into the formula, see? it didn't know that our sine of alpha was going to also be negative. All right, so what's left? You got to figure out this spot and sine of beta, that spot. So we need two things, and they're the beta things. All right, this is the part where you have to draw the triangle for this info in the right spot, label its sides, figure out, don't forget the negatives, and then they're going to be asking you for cosine of beta and sine of beta. Well, actually, they already told you sine of beta, didn't they? There it is. Sine of beta is root 10 over 10. That goes here. So all you really need is this one, cosine of beta. And you won't know it until you've drawn it in the right quadrant. By now, I hope you know it's in here. All right, so I'm going to let you finish that off. And the final answer is to multiply all this stuff together. This times this minus that times that is your final answer. And amazingly, they usually end up with a common denominator, and that you can simplify it down and stuff. This one has a denominator of 50. I'll bet you that'll end up with a denominator of 52. If it doesn't, then you got to make common denominators to add them together. All right, I know that was intense, but that's the same exact kind of problem as this next one here. That one you're going to need to do yourself. Same as I just did a second ago. Alpha's triangle is that. Beta's triangle's in quadrant 2, blah, blah, blah. Oh, quick note. Do you remember? That's over 1. A lot of kids get stuck on that, so I'll put that in there. Okay, so you're going to get two separate triangles, and then you got to look up this formula on your sheet, write it out, and it'll need, well, cosine of alpha plus beta. It'll need cosine of alpha and cosine of beta minus sine of alpha and sine of beta. I just read it off the sheet. So I need those from these triangles. So make a triangle for this one. Make a triangle for that one. Then write out the big honking formula and get your cosine of alphas and sines of betas from these drawings here. All right. So that's the challenge for today. Only one other thing that I need you to do, try this one. And I'm going to just stretch you with that one. And that's the last problem, the one with the, what's this theme again? Can't remember what these guys are called. Hello Kitties. The last one is the Hello Kitty problem. After that, you may skip. Okay? That's the new stuff for today. I will be proving more stuff tomorrow when I'm back. I have a sub the rest of the day, so I had to make this lesson kind of short.